Today's lesson is on using elimination to solve for linear relations. Okay, as a warm up, let's take these four statements and I'm going to be adding or subtracting downwards so that I end up with 0. What do I need to get 7t and 7t to equal to 0? An add or a subtraction sign? Put a subtraction. 7t minus 7t is equal to 0. Okay, what about this one? 36x and negative 36x. Am I going to add these two numbers or subtract these two numbers in order for us to get 0? Right, we need to add because if I add, I'm adding a negative number, which is the same thing. It gives us 0. Okay, let's look at this one, negative 4 and negative 4. This one is a little bit tricky, but I need to have a subtraction in order for us to get 0. Because I have negative 4y minus 4y, and that would simplify to negative 4y plus 4y, and that gives us a 0. So the two negatives became positive, and it gave me a 0. Now this one, negative 8 and positive 8, if we added these, this would equal to 0. Okay, so the reason we did that activity is because using elimination is very similar. We're going to be adding our system of equations downward and trying to eliminate one of the variables so that we could solve for the other one. Okay, let's take a look at this equation. I have 3x minus 2y is equal to negative 5. The second equation, 3x minus 3y is equal to negative 2. Let me just rewrite that here. 3x minus 2y is equal to negative 5. And 3x minus 3y is equal to negative 6. So with these two, I see that my 3x terms are exactly the same. If I subtracted these two equations going downwards, then I would eliminate this completely. My second term, let's write this on the side. This would become negative 2y minus 3y. Two negatives become a positive, and my new statement is negative 2y plus 3y, and that adds to a positive y. So I have positive y, and on the right-hand side of the equal sign, we have negative 5 minus 6, similar to this one. My two negatives give me a positive. So really, I'm saying negative 5 plus 6. That gives me a positive 1. So just to write that out again, negative 5 minus 6, and that's equal to negative 5 plus 6. Okay, we've solved for our first answer. And once we have our first answer, we can substitute this back into an original equation. So 3x minus 2 times 1 is equal to negative 5. 3x minus 2 is equal to negative 5. Let's rearrange the equation. 3x is equal to negative 5 plus 2. And 3x is equal to negative 3. So x is equal to negative 1. We have our y value, we have our x value. So we can have our solution, x, y coordinate is equal to negative 1 and positive 1. Let's do another question now. 3x minus 2y is equal to 4. X minus 2y is equal to 4. Now, since my middle term here, negative 2y and negative 2y is the same, I know that if I subtracted them, I would be able to eliminate my y term altogether. So the reason I say we can eliminate it is because we would have negative 2y minus 2y, minus 2y. So that equals negative 2y plus 2y, and that gives us a 0. So everything else, let's just subtract. 3x minus x is 2x, and that equals 0. When I simplify, x is equal to 0 altogether. Let's substitute this into one of the original equations. Sub x is equal to 0, and I'm going to put it into equation 2 because it looks somewhat easier. 0 minus 2y is equal to 4. So y is equal to negative 2. Our solution is an xy coordinate, and we have 0 and negative 2. Let's do another example. So we have a and b. Same thing, these are variables. We're going to use those instead of x and y now. Just looking at this, I see that the a term is exactly the same, which is good for me because I can just subtract my two equations. 3a minus 2b is equal to negative 10. 3a minus b is equal to 15. Let's subtract. After I subtract, the a's are subtracted out. It's gone. Negative 2 minus 1. That gives me negative 2 plus 1. So we have negative b, and this is equal to negative 25. B is equal to positive 25 because we always have to have a coefficient that is positive here. Now let's substitute this back into one of the original equations. Sub b is equal to 25 into equation 1. So 3a minus 2 times 25 is equal to negative 10. 3a is equal to negative 10 minus or plus 50. 3a is equal to positive 40, and we're going to have a fraction answer here. A is equal to 40 over 3. We have our x and y value, and so we have our solution of x and y as 40 over 3 and 25. Let's look at this example now. 6x minus 3y is equal to 18. The second equation, negative 3y minus 8 plus 4x is equal to 0. Now, it's a little bit tricky to line things up when they're not written in the same order. So I'm going to put a little note here. It is more organized to write it in the form ax, so a coefficient and x, plus a coefficient and y is equal to c, being some sort of number. So my second equation, I will rewrite equation 2 as 4x minus 3y, and I'm moving the negative 8 to the other side. That gives me a positive 8. So my two equations together now, 6x minus 3y is equal to 18. 4x minus 3y is equal to 8. The nice thing here, negative 3 and negative 3. The two negative 3's, I know that if I subtract, I'll end up having negative 3 plus positive 3, and this eliminates my whole y term. Right, so 2x is equal to 10. When we simplify that, we have x is equal to 5. That's the first half of our answer. Let's do the second half now. Sub x is equal to 5 into equation 1. 6 times 5 minus 3y is equal to 18. 30 minus 3y is equal to 18. Negative 3y is equal to 18 minus 30. Minus 3y is equal to negative 12. And we get y is equal to positive 4. We have our solution. Our xy coordinate is positive 5 and 4. Great. In the next two slides, slide 6 and slide 7, I'm going to let you try this on your own. Please pause the video and try these. I will give you the solution in just a moment. Great, solutions to slide number 6. Solutions to slide number 7. Sometimes there are more difficult questions. And when I say more difficult questions, it's not that it's tricky in the algebra, it's that we need to do a little bit more rearranging and preparing before we can solve by elimination. Now, the trouble here, you'll notice, is that there are no coefficients that are exactly the same. So no matter if I add or subtract, I'm still going to have an x value and a y value. I won't be able to eliminate one of them by adding or subtracting. So instead, when I have that, what I should do is I'm going to find a common term between my two equations. Now, I know that within the x terms, 30 is a common term because I can multiply uh, 3 by 10 to get 30. This is also going to be 30, and we can eliminate it. For this, multiply those together, I could have 6, and I'm going to eliminate it. Now, what I'm going to do is I'm going to eliminate the y term. So I'm going to multiply the first equation by 3, and the second equation, I'm going to multiply it by 2. Now, let's write a little note to explain why we're doing this. We decided to eliminate y, and to do that, we need to find a common term. So if I multiplied the whole first equation by 3, I would have a 6. And if I multiplied the second equation by 2, I would also have a 6. So let's simplify now. Okay, so my new equation, 9x minus 6y equals 6. The second equation, negative 20x plus 6y equals 16. Now, the two y's, I can add these two equations, and y is going to be eliminated completely. This gives me negative 11x, 0 here, and 22. Let's simplify by dividing both sides by negative 11, and we get x is equal to 2. Let's substitute x is equal to negative 2 into equation 1. So we have 3 times negative 2 minus 2y is equal to 2. Negative 6 minus 2y is equal to 2. And we continue to simplify. Negative 2y is equal to 2 plus 6. Negative 2y is equal to 8. And we get y is equal to negative 4. We have our two values. So our solution, x and y, is equal to negative 2 and negative 4. Now, a question like this, there's a lot of simplification that we need to do before we are able to simplify using elimination. So in the first equation, I've got fractions. The strategy I'm going to use with fractions, I would like to multiply each term by the common denominator so that I can get rid of the fraction. We take 3 times each term. This simplifies to 6x minus y is equal to 1. Right? Equation 1. Second equation, 3 times x plus 1 minus 2 times y minus 3 is equal to 11. Let's simplify it. 3x plus 3 minus 2y plus 6 equals to 11. Let's keep simplifying. 3x minus 2y is equal to 11 minus 3 minus 6. And we have 3x minus 2y is equal to 2. We have our two equations now. This is equation 1, and this is my equation 2. Let's rewrite this to solve. 6x minus y is equal to 1. 3x minus 2y is equal to 2. I'm going to multiply the second equation by 2 so that I could have 6x as the common term to eliminate. So let's rewrite it. 6x minus y equals 1. And then we have 6x minus 4y is equal to 4. I'm going to subtract the terms now. We have 0 x's. For the y's, negative y plus 4y. That gives us 3y, and that's equal to negative 3. Y is equal to negative 1. So we've got our first one. Let's substitute it back into an original equation. Now, I could substitute it back into one of these, but it makes it really messy because we have fractions and we have brackets. So these are the simplified versions, and I'm going to use this as one of my original equation. Okay, so substitute y is equal to negative 1 into, I'll choose equation 1a. I call this a because it's the simplified version. So 6x minus 1 is equal to 1. 6x plus 1 is equal to 1. And we have 6x is equal to 0, or 1 minus 1. 6x is equal to 0, and x is equal to 0. The solution that we have, x and y is equal to 0 and negative 1. Right. Slides 9 and slide 10, I'd like you to try this on your own. Pause the video and I'll show you the solution in a bit. Right, solution to slide 9 and solutions to slide 10.